like any executable file. Okay, so it's just a simple program that you'll install like any executable file. Same will apply to dev C++. Okay, same will apply to dev C++. And Microsoft Visual Studio will take a different form because it's a huge and a bundled together compiler for so many different languages. And of course, at some point, it will be very difficult for you to be able to access it unless you can access it well and good. But as I mentioned earlier, these are the open source that you can easily use. Okay. Now, so if once you install your code blocks, the information that will be displayed will look like what is on my screen. Okay. And so if you this side, you can see number of projects that have been written in this machine. Okay, so those are sample projects that not project really, but sample simple programs that have been written in this machine before. Okay, on the left hand side, we have certain links. Create a new project, open an existing project, visit the code blocks forums, and request a new feature. Okay, request a new feature. So all these can be used to all these can be used in trying to Hello Biko, what is the issue? I've not muted anybody's mic, so kindly ensure that your background is very silent. Otherwise, you can mute your speaker so that the background noise does not get to us. Reba Koi, can you get me? Reba? Okay. Yes, so you can see those links. So these links will be very beneficial to us. For now, we are only going to use this. Create new project. Okay. So once you open your code blocks, you'll have a screen of this nature. Okay. Then you can click on create new project. Then it will open a sub window there with all those details. Okay. So with all these details, these are all types of projects that you can run in a compiler environment. Okay. There is a VR project and so many others that you can run in a compiler environment. Now, for learning environment where you don't really need to go to write huge programs because the timing will not allow, the semester schedule will not allow for that. So we write what we call console applications. Okay. You write what we call console applications. Okay. Those are programs that can easily be run on command line, and you can be able to view the feedback. So it can be 1 line, 2 lines, 4 lines, or whichever number of lines that are there. Okay, then you can be able to view and see the errors, see the different output that comes out. Okay, so we're going to work on a console. So you'll select console, then you click go. Then another window will appear. This is not very, very important. You can just click next. You don't have to. Maybe you can just say skip this page next time so that it is not shown when you when you're working on your you're opening a new program next time. Okay, so you can just click next. Then here you choose which language you want to use. So you can see C++ here. You can see C language there. So you choose which one are you using. So for us, C language is what we are using. Okay, C language is what we are using. Okay, so you select it, then move to next. Then you have a number of fields there that you can fill. There is project title, there is the storage location, there is the project name, and then there is the path. So the path will take its own course. It's a directory. Okay. Now here, there's this small box. Okay. It's supposed to be used to select a storage location. So if you want to get your storage location of your own choice, you can click on it. It will load up. Okay, you can click on it. It will load up. It will load up, and you can create. I'm sure at this particular level, you're good with creating folders and all directories within a Windows environment. Okay, so you can create a folder from this particular end. Then you choose that folder for location. So maybe, for instance, let me say I'm going to work on the desktop. So I'm just going to say yes.
So we can see the steps in the screen.
Is that the same thing with others? Kindly confirm you can see the last step that I've mentioned on the screen. Yeah, if you can see, you cannot see the screen, kindly just press F5 for that particular page to be reloaded. Then once it is reloaded, you can join again using maybe the microphone. Because on my side, I've shared the screen, okay? So there's really nothing else I can be able to do. My expectation is that it's showing on your side, because I also have... yes, Ruba.
Yeah, now I can see it.
Okay. Yes, so I'm saying that that's the only way you can approach it, okay? Now, moving forward, so I'm saying that once you decide where you want to put your diagram, or not diagram, but where you want to store your content, okay? Once you select where you want to store your content, then you can create that folder, okay? You can decide where to create that folder. And I was saying, I'm sure currently you're good with the simple steps of creating a folder. Okay, so like mine will be stored in a folder called Abdi on the desktop. Okay, so you can create your own folder, then you select it, whatever direction or whatever directory it has been created on. Then the name here, you can give it any name. So I can give it sample one. Sample one. And of importance is this. You can see the compiler or the software provides that particular piece of program with a default extension. Okay, with a default extension. Just the same way Word will provide docs for its own documents, and Excel and so on will provide their own. Okay, that's the same thing that happens here. Then you can see now the path has been chosen. Okay, you can see the path has been chosen there, depending on the locations that I did choose from that particular end. Then I can just click on next, and these settings here, you don't need to change anything. These settings here, you don't need to change anything. Unless you're trying to debug your compiler, it's giving you a lot of problem. Otherwise, this one don't change anything. This screen here, don't change anything. Okay, unless you're trying to do a debug on your program or on your compiler. Okay, then you can just click on finish, and just click on finish. Okay. The reasons as to why you're developing that program. Now, that thought process will help you to design that program. Okay, that thought process will help you to write, to design that particular program. Okay, so step 2, you'll need to design that program. Okay, now the design here is the solution you're providing. Okay, after you've thought about it, you design it. Now the design is what you're going to implement. Just the same way the architectural design will be done. Somebody will think about an house, then you give your proposals to an architectural design or an engineer, an architect. Then he's going to come up with a plan, the architectural design, to provide you with the house. Okay, so that's the same thing here. Now in this design here, there are design tools that we use. Okay, there are design tools that we're going to use. So there is a flowchart that we use in design. There is what we call a pseudocode. Okay, there's what we call a pseudocode that we also use in design. In advanced design, like what you're going to do in system development or system analysis and development, you'll be working on several design softwares or several designs to UML and so on and so forth. Okay, those are advanced design. But for basic learning processes of introduction to programming, you can design your programs using a flowchart or using a pseudocode. Okay, so based on your design requirement, you'll choose what works for you best. Okay, you'll choose what works for you best. So in design, I've said pseudocode or a flowchart. Maybe I'll show example of one or two designs that have been done either with a flowchart or a pseudocode. Then you can be able to see that. Okay. Then step 3 or stage 3 is you need to put down the program. convert the design into a working solution. Okay, these are across the board, whether you're using Python, you're using Java, it's across the board. Everything will have to go through the same processes. Okay, so you pick your language of choice, translate your design into a program, pick the best editor for that language you've chosen, that programming language you've chosen to use for editing your program. Of course, editors are integrated together with compilers. So once you choose a compiler for that language, if it is NetBeans for Java, then here you go, you have your editor embedded within that particular compiler. Okay. Then you do the compilation. Okay. So this is the translation process. You're trying to get your feedback from the compiler. Okay. You're trying to get the output from the compiler to check whether you have errors, whether you have successfully written your program and compile it through. I remember last week I was talking about the relationship between int main and return 0. What happens between those two? The function int main and the return 0. What happens between those? So that's part of the error checkup. Okay, so you need to code your program very well, run it or execute it or compile it using the right compiling tool, and then be able to check for your errors. So if you have errors, don't move on. If you have errors, don't move on. So saved here. It says here. The compiler also checks errors in your program and reports the error to you for correction. So you can't move on if you have errors. One of the source of errors is syntax errors. These are very, very common type of error. Maybe I like types of errors, but syntax error is a very common type of error. Okay. Anytime you don't follow the correct procedure, the correct rules of a given language, you end up with a syntax error. Okay. So I'll be pausing for 30 seconds or 1 minute as you take notes for those who are taking notes. So number 5 is run. So run and compile are almost in one access point. So within the compiler, there's those 3 steps. Okay, there's those 3 steps that you'll always follow while trying to do your work. So you will compile, you will build. So you'll compile, okay, compile, build, and then execute or run. okay, execute or run. These three processes are all in the compiler, okay. So if you are building, what you're doing is you're trying to bring on board the library files. I'm sure you remember what I was talking about. Hash include stdio.h, okay. So you are putting the link together. You are bringing on board those library files to allow you run this particular program. So build and run can either be done at the same time, depending on which type of compiler you have. And the statement here is explaining very well that this is the actual execution of the final code, usually preceded by the linking of the hash. Hash, I said, all preprocessor commands will always begin with a hash. So everything that we were instructed to include within the program or to add or to check is being done at that particular point when you are building, okay. So once the build is complete, then the execution or run can be done so that their final output can be displayed. So there is compile, build, and run. Then you can check for errors in that program through testing. System analysis will explain more about testing, black box, and all those type of testing that are there, and deployment methods, okay. So here we're only going to do one type of test. You just test our programs using what we call test data, okay. Just trying to feed in some inputs and see if we can be able to get an output from there, okay. So you test that particular program by using test data to check if it's producing the right output and is able to contain the necessary output or input that is expected. Then 7, you maintain the program. And also this will be explained deeply in system analysis and development, types of maintenance, and of course the documentations that follows up through the maintenance process. Those ones will be explained in system analysis and development. So here, maintaining and modifying the program involves you trying to be able to remember I talked about comments, okay. So comments are part of the maintenance of a program. Put comments on each line that you think is very important in that program, okay, so that the maintenance process and modification can be done with a lot of ease. We can be able to know if this program was processing 1,000 results of students per hour, okay, what do we need to do to either modify it to be able to do 2,000 or so. There's that line of program that was able to do that particular processing. Or there's that comment you said, if you're changing this, then you go back to the hardware requirements. So you go back to the server or you go back to the network bandwidth and change one or two things so that that program can be able to accommodate that. So program design tools, remember I've just underlined that word here. Okay. Program design tools. Okay, so those are the tools that I mentioned. Okay, so we normally say that when in your design process, your architectural design should be this, an algorithm. I'm sure that's a word you've had quite a while. So in your design, your output should be an algorithm. Okay, is basically steps that shows how a solution or a strategy is going to be used to solve a problem. Okay, so you can present your output of the design process, which is called an algorithm, in different ways. Okay, so one of them is explained here, a pseudocode flowchart. Okay, and the description is here. We say this is English. These are English statements. Okay, but now the only difference is they are English statements that are in a given order. Okay, the English statements that are in a given order. So example here, if you are to calculate the pay amount for 5 employees, okay, what do you need to do? Okay, so we are saying we start at this point, then we initialize. You enter the details of the employees to the computer, including the pay. Okay, then you increase the counter by 1 because you want to do it for 5 employees. Okay, so if you began at 1, then you need to move up to 5. So that's why we say increase. So step 1 cannot be overtaken by step 3. It has to be step 1, 2, 3. Okay, step 3. Then step 4. Step 5. Then, of course, N or step 6. Okay, N or step 6. So check the value of the counter. If the counter is less than or greater than is less than 6, then you loop back to step 3. Step 3, we know what step 3 was trying to talk about. So that's what we call a pseudocode. Is English statements that are structured in a specific way. The English statements that are structured in a specific way. Next is flowcharts, another type of design. So flowchart is is in form of symbols. Okay, it's just like the way we've expressed pseudocode, but now we're using symbols to do this particular process. Okay, and of great importance to us are those symbols. Which symbols are we using here? That is the great, most important thing to us. So these are the symbols. 1, 2, 3. So you can just take note if you're putting up some short notes. So these are some of the symbols. Start and end. So start and end, we're using them to show the beginning. Okay. So the details here can be written in, we can use an oval, okay, to show start and end processes. Then process, which is number 2, details are shown in a rectangular box. So it's about computation, is about mathematical operations, is about storage. Later, when you'll be doing your UML in SAD, you'll not be using a rectangular box for storage. You'll use the database symbol for storage. But for us here, if I want to say x is equals to y or x is equals to 3, this is storage. So I can put this in a rectangular box, okay, because we are trying to process 3 to be stored to x, okay. So anything that is involves assignment operator, we are supposed to do a rectangular box. Then input and output should be parallelogram. I'm sure everybody did basic mathematics, not even basic, I don't know how to call it, but it's mathematics from class 3. You know what a parallelogram should look like, okay? So it's supposed to represent input and output. Anytime you want to work with an input or an output, then you use that symbol in a flowchart to show that process. Okay, then the next one, which is going to be number 4, decision. This is a very important aspect in programming. Okay, well, that's what we say. Programs that can be able to relate or can be able to solve real-time or real world problems. That they can make decisions. Okay, they can decide when we meet this condition, then these are the following options that we have. Very, very important in writing programs. Okay. So this is indicated by decision making and branching. We'll be using a rhombus for this. Rhombus is it tilted square, something of that nature. Okay, something that will look like almost like this. Okay, so we have this entry and exit point. So this is an entry point. This is an exit and exit. So remember, we are saying, so if the entry is from here, then we can exit from 3 different places. Okay, so those are all options that we have. So the condition, the statement comes through here, we check the condition inside here, then we exit from either of the 3, depending on which conditions that we are trying to check. So we're going to see maybe an example of that. So then connectors, those are basically showing the flow. They are arrows. Okay, those are basically showing flows or arrows. So that's what make up a flowchart. That does not make up a flowchart. More advanced symbols for design or for algorithm representation, as I mentioned, is in system analysis and design. So the definition of structured programming is provided there. Yes, I see Moti is asking about a PDF for these notes. I can try to put them together in a PDF form. Yeah, I can try to put them together in a PDF. Okay, so types of errors. We can ask a few questions maybe towards the end of the program, of the lecture. We're just about to move to a different thing, then we can stop. You can go and try to put up together everything you've done. Okay, so types of errors. We have 3 types of errors that are very, very important to us. Okay, so we have syntax. I'd mentioned it. The examples are given here of when you get a syntax error. Examples is not conclusive or exhaustive. Okay, types of errors that you associated with syntax error. So meaning you did not follow the syntactical definition of a language, the rules that are provided for there. We have logic errors, very important, because it can, if you're developing an application for the bank, for the banking sector, if you have a logic error that is not doing proper deductions or calculations, then people can borrow or people can withdraw excess money from the ATMs, and it will be so bad on you. Logic errors do not really affect the program execution. If you don't do your testing properly, you will not notice logic errors because they don't affect the working of the program. Okay, it's like you adding 5 plus 2 to get 12 or 25. Okay, so that's a logical error. It will not affect your computation. Okay, but you'll have done a very, very big error in the quality of what you are doing. Okay. So then the semantic errors, not really be concerned on our side. These type of errors are really related to maybe the semantics of the language. There are things that you do not follow the way they are supposed to be. Okay, but the most important 2 types of errors is this and the logic. Okay, and then there's also one that is called the linking error. Okay, it's not mentioned in this handout of the slides I'm using. Linking error. So this will occur during the build process. Okay, so if the library files that you've mentioned as part of the preprocessor directives cannot be accessed, okay, then you will get a linking error. That means we cannot able to link those library files that you are mentioning within the program. That is either because the compiler was not given a full installation, that can be a reason, or the compatibility issues. Maybe your operating system is not compatible with that compiler, and so many other things about installation, about the quality of installation that was done. Okay, so the one that you will mostly find in your program is the syntax errors. That's a bigger one, the primary one. Okay, then linking errors once in a while, especially with those who will be using code blocks to try and program their pieces of code. You are likely to get linking errors because of the quality of that compiler is not that 90 or 80% sure. But if you're using dev C++, you are likely to find linking errors. It's a very stable compiler, so I'll encourage you to go for that while you're trying to get your compiler. Okay, so so logical errors are explained further here. The bigger picture is omission. You can call it in the English in communication skill as an omission error. Okay, so that's a bigger picture there. Then semantics errors, illegal expressions cannot make sense to the computer or to the compiler. That's what I was talking about. So it's not really something that will experience most of the time. Okay, it might happen especially when you're dealing with files, so that you'll be able to get this type of errors, data overflow. Okay, where you've the size of the file was not really declared enough to contain the data that is being stored in that file. So you get overflow errors and so on and so forth. So those type of errors will come much later in a bit of towards the end of the structured programming class. Okay, so structured programming defined, you can go through those ones maybe when I share those notes to really try and understand the advantages of structured programming and why it's one of the most adored type of programming. So I'd mentioned C language. I'll not go back into that. Use friends and the type of languages that they share one or two things about. So I'll not go back into those ones again. So maybe I can just mention this. I'd given an example last week. We can just have a look at it again, but I'd given an example. Okay. What a typical C program will consist of. We had talked about these ones.
Sir, share the slide screen.
Yes?
Share the slide screen. I cannot see.
data types. Confirm you can see what I've shared. Having a bit of a challenge here. Yes, confirm you can see my data types. So another important aspect, Catherine, can you hear me? Catherine, can you hear me? Yes, so I'm saying that in C language or in any other programming language, data type is a very important aspect. For you to control the memory locations in a computer program, you need these data types to do that. Okay, so these are the primary data types that we have. So data type is a special word, or is a word with a predefined meaning in a given language. Okay, it's a word with predefined meaning in a given language. So like if you want to create a memory location for a given type of data, then the compiler would require the data type so that it can communicate with the operating system to allocate a memory for that data type. Okay, so these data types that we have will take different size of the memory. Okay, and of course the type of operations that can be performed on each data will be different. So the way you are handling a character is not the same way you'll handle an integer, it's not the same way you'll handle a float, and it's not the same way you'll handle a double. They have different types of mechanisms. So if you want to handle each, then you'll have to give it a special treatment. So how do we treat them? We treat them using the keywords here. Okay, we treat them using the keywords here. So for character is CHAR. For integer is INT. For float is FLOAT. And for double is actually double. Okay, so character here is anything that involves a symbol, that involves a letter, that involves a number, especially, for instance, your password. Your password is going to be treated as a character. Your registration number is going to be a character. Okay, so sometimes some will be using the word string. Okay, especially moving to object-oriented programming, we'll be using the word string. Okay, we'll be using the word string to represent character. Okay, but character, your registration number, your password somewhere should be in form of a character. Integers are the numbers, and I loosely call them 0 to 9. Okay, I loosely call them 0 to 9. So anything that falls within that range that makes use of the numbers 0 to 9 is going to be an integer. Float is supposed to be what we call in mathematics numbers with fractional components. Okay, numbers with fractional components. So if we have 3.142, that number should be treated as a float. Okay, double is a representation of either an integer or a float with a bigger storage requirement. So for instance, maybe you have 1 million to be represented, or you have 10,000, or just any other number that is bigger. I'm going to maybe I'm going to share with you the ranges that is expected for a double. What is the size that we can allocate for an integer, for a float, and so on and so forth. But for now, let's just know integers are the simple numbers that we know, but without the fractional part. Float are the numbers we know, but with fractional parts. That's very important for you to be able to know. And the keywords here, okay? The keywords here are very, very important. Okay, so when we'll be defining our variables, these data types will be part of what we'll be using. These data types will be part of what we'll be using. So examples are given here. Float F, double D. So these are variables. F is a variable. Float is a data type. Okay, so these are how we declare a variable. These are how we declare a variable. Okay? So what we have done here is we are saying allocate us a temporary memory location for this variable called D. And the memory location being allocated should be the size required by a double. Okay, so these data types are defined. The compiler knows the number of bits or the number of MBs that is required for this type of data, and the operating system. So that coordination, I'm sure you learned about functions of the operating system. So that's part of what the operating system will be able to do. So you see here, this is the number we are trying to represent, maybe 234.936, and we are saying we can declare that as a float. Okay, so there's approximation here, 8 bytes. Not really sure. This is not is not an accurate size, but now that's an approximation of what a double will require. Okay. So more declaration or more examples on how to declare variables, we're going to see them once we start writing our programs. Now, statements that are used in a C program to display numbers or to read numbers. Very, very important to display numbers or to read numbers. I'd mentioned printf, okay, as the primary output function last week, okay. So it will take different shapes depending on what you really want to do. It will take different shapes depending on what you really want to do. Maybe let me get an example of a program, then I can explain all together. Yes, these ones. This table here, very, very important. This table, these characters are called escape codes. Escape codes. Okay, these characters are called escape codes. If you're working with a character, you need %C. If you're working with an integer, you need a %D. If you're working with signed decimal values, you need %I. If you're working with a scientific notation, %E. If you're working with a scientific notation that requires lowercase, you need %E capital. Now, these three are not really important to us. Those three, will not use them so much. We'll replace I with D. So D will work for us both for signed decimal integers. We'll slightly ignore I for the time being. So these three will not be very important to us for now. Okay. The one that is missing or should be in the next page is %F. Okay, %F.
Sir, please share the screen.
For float, you cannot be able to. What's happening?
You cannot.
My screen is on and is shared. What's happening? I don't know. Any other person who is not able to see the screen? Okay, I'd set up your speaker so you can always let me know if you cannot hear me, because I'm using two different screens. The one being presented to you and the one that I'm able to write on and be able to indicate a few points there. So I'm using two different screens. So if you cannot be able to see or hear, use the voice. I'm not be able to see the charts, okay? Because I'm using two different screens. The one you are using is the display one. So if you cannot hear me, you can use the audio so that I'll be able to hear somebody speaking. Yeah, can you see the screen with the characters? %C, %D, %I, %E, %E capital. Can you see that screen?
No.
Yeah, we can see.
So some people can see. If you cannot see that, maybe there is a connection. Always just press F5, try to refresh the screen and be able to join again. You might be able to see it. It might just be connection problem. Okay, so I'm saying these are called escape codes. These are called escape codes. We use them with the data types that we were talking about, the characters, the floats, the integers, the doubles, and so on and so forth. Okay, so we use them together with those data types that are there. Maybe you can write a simple program just to try and elaborate on some of these things that we are talking about. I don't know if we'll be able to see that or not. Let me just check. Now, so if you can see my screen, there's a program I've opened up there. I'm going to give it numbers. Each line, I'm going to give each line some number. Okay. I'm going to give each line some number. So number 1, number 2, number 3, number 4, number 5, number 6, number 7, and number 8. Okay. So these are simple programs that these are simple programs that we're going to use to explain simple program that we're going to use to explain how the variables are declared and how basic input output is done. Okay, how basic input output is done. No, you can help your friends. There's some people still sending me messages that they're not able to log in, so I don't know. Okay, you can help them out. Because if I log out and go back to check what's the problem with them, we will not be able to log in again. I think the time for joining the session is done, so you'll not be able to join. Now, so this program here is explaining two important things: variable declaration and output statement. How do we display data to the screen? How do we display data to the screen? Now, number one is a preprocessor directive for input output. I think we had mentioned that standard input output header file. Okay. Number two, we had also mentioned that the main function, I said it is the parent function where all other functions within the program depend on for execution. Okay. So these two, almost all C programs will have those two first lines. Okay, they'll have those two first lines. This is the opening curly brace showing the program body is beginning, and it is closed. Should be in the next page, but should have been closed somewhere here. Okay, closed there. Shows that the program body began at that line and closed at that line. This number four is a set of variable declaration. Different variables have been declared. Different variables have been declared. Number one, we've declared a variable called ch of type character. And then you terminate with a semicolon. Very important. Number two, we've declared a variable called f of type float. Number three, we've declared a variable called d of type double. And the last one is not a declaration, but we are doing what we call an assignment. This here is called assignment operator. Okay? That one there is called an assignment operator. An assignment operator. It assigns character X to variable ch. Assign character X to variable ch.
Just a moment, sir.
Yes.
I can't see the screen.
Yes.
I can't see the part you're sharing on the screen.
You can't see the part I'm sharing on the screen.
Yeah.
Any other person who is not able to see that? Any other person who is not able to see that, kindly refresh your content. Kindly refresh your content. Refresh your content. Okay, I was just mentioning this. Elder Queen, are you able to see or not? I just see you've typed yes. Elder Queen, are you able to see or not? Yeah, so I was trying to explain that. So I hope you can just refresh and try to see if you can be able to see what is going on. Okay, so that's what we are doing. So we've assigned X to this variable called ch. We've assigned X to that variable called ch. Okay. Then the next line here, we are assigning a value to f. Remember, I've said the equal sign here in mathematics is not an equal sign in programming. It's called an assignment operator. We'll see what an equal sign looks like in programming. Okay, so in programming, our equal sign will be a double one. In C, in different languages, it's different. In C, our equal sign will be a double one. Okay, so here we call it this an assignment operator. Okay, we are doing the same to D. We are assigning a value to D. And you can see that the end of each statement here has a semicolon. Within the program body has a semicolon. Very, very important. If you miss that, you're going to get a syntax error. Okay? Then we are printing out these values. We are printing out these values. Look at those printf statements. Look at those printf statements. We are printing out those values. What is you should be able to see is this conversion specifier or the escape codes. Conversion specifier or the escape codes. They are used to check, is this output coming from memory location CH, a type of character, the way it was declared initially here. Okay, is it still the same? Okay, if it is not the same, you might not even view the output. The output might not be able to display. So you can maybe try and change that and see what comes out. Okay, the same happens here. We are checking, is what stored at F still a floating point number, the way it was declared? And the same happens with the D. Are we still working with a double? Okay, so what I would love to mention here is that these characters before %C will be displayed the way they are. The compiler is not interested in knowing what exactly you wrote there. So the compiler will display that the way it is. It will not struggle trying to really look at it and come out with the meaning. So what the compiler will interpret here is, did you have the two double quotations? Yes. Is %C correctly placed? Is CH correctly placed with a comma in between? And is the statement well closed with a semicolon? The rest, in between the double quotations just before %C, is not a concern to the compiler. It will not check what you've written at that point. Okay, so this is one form that printf will take in terms of displaying content. There are several forms. This is just one way of displaying content using printf. Okay, that's just one way of displaying content using printf. Yes, any question up to that point? Any question up to that point? Question up to that point? Any question up to that point? Swali?
Yeah. So you had mentioned somewhere something to do with int and main.
Yes.
I just forgot to put something down about it. Can you give me something on it?
What exactly? Int and main?
Yeah.
Okay, I was saying, now maybe at this particular point here,
Yeah.
at this particular point here, sometimes we say int main. Okay, sometimes we say int main. This integer here, really what is expressing here is that the main function here should return the number of errors in form of integers. That is why we are saying it will return a 0 if we don't have an error, but it will return any other integer if we have an error. That's the meaning of this. It's not mandatory, but depending on the compiler you're using, some compilers will not be able to run main without an int with a return 0, because the compiler will tell you the main must return a value, meaning it's not defined what the main should return here. So int main is not a must, but depending on which compiler you're using, some compilers will not be able to run a main without an int, because they'll compiler will see a return 0 here, okay? And that means there is a mismatch. Return 0, but here the data type is not defined, okay? It's just the same thing we are saying here. If D was a double, then printing D requires a %D, okay? Or a %F or whichever, okay? So it's the same thing here. So int main should return an integer in form of a 0 or any other integer. But I've said it's not mandatory. If you run this program in different compilers, I don't know which compiler is going to reject this. I think it should be Microsoft Visual Studio or code blocks, but dev will run this program the way it is without the int, and it will be able to work perfectly very well. Okay, so that's what I was saying. So int sometimes goes with the main to show this, but it's not a must.
Thank you.
Okay. So the not deeper explanation, but explanation for more is given here.
Excuse me, sir.
Yes.
You say that when we're using character, we can also be able to. It can read characters, both strings and letters and numbers. And when we only want to read numbers, what can we use?
If you're working with numbers only, then those ones should be integers. Those ones should be %D.
%D only.
Yeah, if you only use character if they are mixed.
And when we use %I,
%I can also be used in with decimal numbers.
mm-hmm.
Is another version of %D. So depending on
%I,
yes,
%I can also be used in floats.
No, %I should only go with integers.
Oh, yes.
Yeah, %I and D will go together.
Okay, I've understood. Thank you.
Okay. Now, so maybe I can just show you how to run a program in code blocks, then we can stop there. So I can just pick this program here.
Ukiwa katika barabara kifani waweza kujuza hali kwa vipi pande hizo ili tuweze kufahamisha wananchi. Lakini kuna chochote barabarani unapokuwa uko kote nchini Kenya, tafadhali tumia SMS Baba Jambo kwa nambari ya 22494 ukianza na neno jambo tafadhali.
So I'll go to I'll go on the left side of the screen, on the left bar, where it's written management. There are projects there. There's workspace. So once I open up my program, the way I mentioned earlier, I just go to sources and I'll be able to get the first sample of a program written as main.c. Okay, the first sample of a program that you can use. Okay, so maybe I can try and okay, I think maybe you just do it with it the way it is. I'll try and enlarge it maybe when we meet next class. There is something I'm missing to be able to enlarge that. Okay. So this is where you will be able to get your content. So there's build. So from build there is compile, there's run, and there's build and run. That's the processes you'll take your program through. Okay. So for instance, if I compile this program, if I compile that program, down on the screen here, though maybe on your side it might not be clear, down on the screen here, where I'm doing the my lighting, there are a number of errors and possible warnings that have been executed, and of course the execution time is displayed down here. So this is where you checked for your error. So if I had an error, it will be displayed here. If I have an error, it will be displayed here. Okay, that is after compilation. Okay, then next you should go and build your program. Okay, so you can build and run, they can go together. I'd mentioned that. Okay, they can go together. So you can build and run, and then you'll see the black screen that is popping up. Black screen that is popping up. I'll have trouble sharing the screen. Be forced to share that screen on its own. Okay, so if you build and run, you should be able to get a screen similar to the one I'm trying to display. Okay, yeah, you should be able to get a screen of this nature, and the output here is hello world, the one I'm putting in red, the one I'm highlighting in red, hello world. That's the output. So if you look at your program the way it was designed, then the output statement printf was designed to display on the screen hello world. Okay, the program was designed to output on the screen hello world. Okay, so that's the first step on how you access your code blocks and how you write your code blocks program. Okay, So this is the screen, this is the output screen. A command. That's why we were saying we are doing console. So this is the console output. Okay, that is a console output that we have there. Yeah, so I think if there's no any question and upload the content, you can try them on your own, then report back next week what the challenges you had or where we need to really explain further. So just try, you can copy the programs in the notes and share. Copy them and paste them there, and then just try to run them off and see what is coming out. Try to find errors and so on and so forth. That's all about what programming is all about. It's a bit of trying. You just have to be somebody who loves trying and not giving up. Okay. Yeah. So I'll end today's lecture at that particular point, and hope we get to meet next week on time so that we move together. Okay. So unless there's a question, we can end our topic there. In the next maybe 15 minutes or 30, let me say 30, I'll have uploaded the notes there. I'll upload them in Word form. Somebody wanted PDF, you can convert them in PDF. Okay. Yes. So you're free to exit unless you have a concern. Yeah, Karani is asking PDF. I'll put in Word. You can convert to PDF, or I put in PDF. Yeah. So you can exit the class. Thank you.